Questions 21 to 25 on the 2004 Grade 11 Fermat Math Contest. Bill and Jill are hired to paint a line on a road. If Bill works by himself, he could paint the line in B hours. If Jill works by herself, she could paint the line in J hours. Bill starts painting the line from one end, and Jill begins painting the line from the other end 1 hour later. They both work until the line is painted. Which of the following is an expression for the number of hours that Bill works? In this question, they want you to figure out the final answer in terms of B and J. And from my experience with questions like this, it's much simpler to just use some numbers. Assign some numbers and work with those. Because if you're going to be talking in terms of B and J all the time, this is going to get very confusing very quickly. And what's the point of that, right? Why make your life difficult? So let's use some numbers. Let's say this is our line that they want to paint. And initially, this road, I'll give it anything you want. Let's call it 100 kilometers in length. All right? And Bill, let's say it takes him 50 hours to complete painting this line. You can use any numbers. I just wanted to use easy numbers. So if he paints this road all by himself, it's 50 hours, so therefore B is equal to 50. This B that they're talking about in the question. Now we will calculate his painting speed. Just like how you have speed with regard to driving a car or something like that, his painting speed is 100 kilometers over 50 hours. And that is 2 kilometers per hour. That's the pace at which he's painting. And now let's turn our attention to Jill. Jill basically has a very similar kind of scenario, but let's say she's painting a little bit faster. So instead of 50 hours, she's able to complete the task in 40 hours. Same road, same distance, right? Her painting speed, therefore, will be 100 kilometers over 40 hours. And that is 2.5 kilometers per hour, her painting speed. And therefore, this J that they're referring to, I've set as 40. All right, so that is the initial setup of the question. Now I'm going to draw a similar line, but now let's use the criteria in the next part of the question. They're saying that Jill and Bill are going to start painting, but from opposite ends. So Bill starts from here and Jill starts from here, and they're going to go in opposite directions like that. But there's a very important thing that I don't want you to miss, that Jill starts painting 1 hour after Bill starts. All right? So Bill starts, and then for 1 hour, he's painting all by himself. So we have to figure out how much did he paint in that 1 hour. All right? And then we'll start talking about Jill. Well, Bill basically paints at a rate of 2 kilometers per hour, 2 kilometers every hour. So in 1 hour, he would paint 2 kilometers. Right? So this distance in here is 2 kilometers. And this is 1 hour. Okay, now Bill starts to continue painting, and I don't know where he gets to, but let's just say he gets to here. That distance from there to there, I will label as X, since I don't know. And in a very similar way, since Jill is painting in that direction, she's going to paint from here to here, and I will label that Y. Okay? Now, we know that this whole distance is equal to 100. That's what I've set it as. So therefore, 2 plus x plus y is equal to 100. So 2 plus x plus y is equal to 100. Now, in the same way that I figured out that this was 2 kilometers, I want to figure out what is x in terms of the distance. Well, I can do that. That's for Bill. Bill is painting at 2 kilometers per hour, correct? So if he's painting at 2 kilometers per hour, we've got 2 kilometers in 1 hour. We want to figure out how many kilometers does he cover. Well, that's x. And we don't know the number of hours that it takes him to go from here to here. So I'll just introduce another variable, z. So cross multiply, you get 2z is equal to x, and therefore z is equal to x over 2. This is the hours. So I'll put that over here. This is x kilometers, and his time is x over 2 hours. In a very similar way, I want to figure out what is the number of hours for y. Okay, well, that's Jill. Her painting speed is 2.5 kilometers per hour. And we want to know if there's y kilometers, what is the number of hours? Any variable, q is fine. And cross multiply, you get 2.5q is equal to y, and therefore q is y over 2.5. So y over 2.5 is how many hours it takes Jill to paint from there to there. All right? So we've got to understand one thing here. The time that it takes Bill to go from here to here is the same amount of time it takes Jill to go from there to there, right? Because that is where they meet. They meet here. And once they meet, that entire road has been painted. So that means that these times are equal. So that means that x over 2 is equal to y over 2.5. And if you cross multiply, you get 2.5 is equal to 2.5x is equal to 2y, like that. And now we're almost done. We have one great equation that we can substitute into our finding here. So let's do that. We got 2 plus x plus y is equal to 100. And let's see here, we can substitute for y. So 2 plus x plus y, which is 2.5x over 2, is equal to 100. And this looks like 1.25 plus 1, so 2.25x is equal to 98. And therefore x is equal to 43.55. All right. Now, what are we trying to figure out in this question? The number of hours that Bill works. Okay, well, Bill worked initially for 1 hour, and then he works for x over 2 hours. So the number of hours that he works is 1 hour plus x over 2 hours. And that is 1 plus 43.55 over 2. And this equals 22.78 approximately. All right? And now all we have to do is figure out which one of these match 22.78. Okay? So here we go. 22.78 is my answer, but they want it in terms of B and J. Well, no problem. I've got B here and J there. And it's perfectly fine to do it this way. And I sincerely hope that you are convinced that using some initial values makes it so much easier to explain and understand. Otherwise, I'd be using B's and J's all over here and be completely confused within, 2 minutes or whatever, 90 seconds. So if I use B equals 50 and J equals 40, and I calculate all of these, the one that matches 22.78 is the first one. And therefore the answer to number 21 is A. If k is the smallest positive integer such that 2 to the power of k times 5 to the power of 300 has 303 digits when expanded, then the sum of the digits of the expanded number is. So just really quickly, I want to show that, let's say k is less than 300, right? Let's say k is equal to 10. You can take this expression and break it up. It would be 5 to the power of 300 times 2 to the power of 10, right? And then you can break up 5 into 10 and 290 like this. And then since these exponents are the same, you can combine the bases like that. And therefore this becomes 5 to the power of 290 times 2 times 5 to the power of 10. But 2 times 5 is 10. So there you go. This is basically some number 5 to the power of 290 times 10 to the power of 10, so that's 0, 0, 0, 0, 0, 10 zeros. See what happened there? So all you have to do is figure out this number here, and then the rest is all zeros. So in a very similar way, I'm going to do that over here. I've got 2 to the power of k and 5 to the power of 300, correct? So 2 to the power of k, 5 to the power of k, but I've got to subtract 300 minus k. Since the exponents are the same, combine the bases like this, and then you get that. 2 times 5 to the power of k times 5 to the power of 300 minus k. This becomes 10 to the power of k, 5 to the 300 minus k, and therefore this is some number 5 300 minus k times a whole bunch of zeros like that. How many zeros? Well, k zeros, correct? So there you go. So we are going to be dealing with this right here. All right, where do I begin? Where do I start? I'm not really sure where k is going to be. Is it going to be a big number, a small number? Is it going to be less than 300, greater than 300? See, I don't have a crystal ball that helps me here. So I'm just going to start with values that make things easy for me. I'm going to start with 5 to the power of 1. All right? If 5 to the power of 1 is what I'm starting with, that means that 300 minus k is equal to 1. Correct? And that means k is equal to 299. So if I have this kind of scenario, my number from up here becomes 5 to the power of 1 followed by a whole bunch of zeros, right? How many zeros? 299. Like that. Well, this is just 5, so I've got one digit here, and then I've got 299, so I've got 300 digits. But our number that they describe in the original question has to have 303 digits. Okay? Well, we don't have that, so let's just keep going. And also, there's another important part, is that the sum of the digits has to be looked at as well. The sum of the digits for this one, since it's 5, then 0, 0, 0, 0, the sum of the digits is just 5. Okay? Let's look at the next one. That would be 5 to the power of 2, right? And 5 to the power of 2 is 25, so the sum of the digits of that is 7, because you're going to have a whole bunch of zeros afterwards, right? That's the way we are pretty much making our numbers. Well, if the exponent is 2, then that means that 300 minus k, in this case, is 2, and therefore k is equal to 298. So we've got 298 of these zeros, and this gives me 25, correct? So that's 2 digits. So the sum of the digits in terms of how many there are is 300. Oh, again, that doesn't work. All right, let's keep going. We can increase our speed here. 5 to the power of 3 is the next one, which is 125, and the sum of the digits of 125 is 8. 300 minus k this time is 3, and therefore k is equal to 297. So this looks like it's going to be 5 to the power of 3 followed by a whole bunch of zeros, correct? Just like up here. And this is 297 zeros, and 5 to the power of 3 is 125, which is 3 digits. So again, we got 300. So what is going on? We're never budging here. Okay, let's keep going. 5 to the power of 4. Well, 5 to the power of 4 is 625. 6 plus 2 plus 5 is 13. But I want you to go back and look at the answer choices. 13 is not one of the answer choices. So I don't need to really even consider that one, because the sum of the digits has to be one of those answer choices. How about 5 to the power of 5? That is 3125. The sum of the digits of 3125 is 11. That means 300 minus k is equal to 5. That was k is equal to 295. All right? So that means this is 5 to the power of 5 with a whole bunch of zeros, and there's 295 of them. 5 to the power of 5 is 3125, which is 4 digits, correct? So this is 299. So we got 300, we got 300, we need 303. And then if you keep going here, 5 to the power of 6, 5 to the power of 7, you'll see that these sums just keep getting bigger and bigger. So what do we do here, right? This is a question where you think, well, geez, I'm stumped here. None of these answer choices are working, and if I keep going higher, those sums keep getting bigger than what's listed. So this is where the challenging part of the question comes in. You have to now go in the other direction. And when I say other direction, what do I mean? Other direction for what? You notice how we're going 299, 298, 297, 295, right? You got to go up now. 300, 301, 302 for k. So if you did that initially, my hat's off to you. Obviously, you saw something that, in my humble opinion, most people would not see. Most people would go in this direction. So let's go in the other direction, and let's see what we get. So again, we got the same formula. 5 to the power of 300 minus k, followed by a whole bunch of zeros, correct? And there's k zeros. And here, well, we don't know. There's a certain number of digits. So we initially can start with k equal to 300. If k equals 300, we have 5 to the 0, followed by a bunch of zeros. And there are 300 of those. 5 to the power of 0 is 1, so that just gives you 1 digit. So that means we have a total of 301 digits. We want 303. So let's keep going. 301 for k. We get 5 and then minus 1 with a whole bunch of zeros. 301 digits, 5 to the minus 1. So that gives me 0.2, right? 1 over 5. So this becomes 0.2 times 10 to the power of 301, like that. And this is basically going to be 2 times 10 to the power of 300. And that is 2 followed by 300 zeros. So we got 300 zeros, and we've got 1 digit right there. So we got 301 digits. All right, we haven't got to that 303 digits yet. Let's just keep going here. K equals 302. Let's see what we get. So that gives me 5 to the power of negative 2 times 10 to the power of 302. This is 0.04 times 10 to the power of 302, which is 4 times 10 to the power of 300. So this is going to give me 4 and then 0, 0, 0, a whole bunch of zeros, 300 of them. And then I've got just one digit there. Again, 301. All right, let's keep going. Let's increase our speed here. It's a math contest. So I got 5 to the negative 3, right, times 10 to the power of 303. And that looks like 0.008 times 10 to the 303, which is 8 times 10 to the 300. And that again looks like 1 plus 300 digits, which is again 301. Boy, they're really making us work for this question. 304, 5 to the power of negative 4 this time. 10 to the power of 304. And this is 0.0016 times 10 to the 304, which is 16 times 10 to the 300. And this is 2 digits followed by 300 digits, which is 302. All right, at least we're getting up. We're getting up in the world, going up in the world, whatever it's called. And then 5 to the minus 5 times 10 to the power of 305. And then that is 0.00032 times 10 to the power of 305. And this is 32 times 10 to the power of 300. So this gives me 2 plus 300, which is 302. All right, again 302. All right, we're getting close to that 303 in terms of the number of digits. 306, 5 to the negative 6 times 10 to the 306. And this is 0.000064 times 10 to the power of 306, which is 64 times 10 to the power of 300. So we got 2 digits, 300 digits, again 302. Well, we're going in the right direction, so we're going to have to get 303 sooner or later. K equals 307. 5 to the minus 7 times 10 to the 307. And this gives me 0.000128 times 10 to the power of 307. And that is 128 times 10 to the power of 300. And this is 3 digits plus 300 digits, and voila, there you go, 303, finally. So now what are they asking for? The sum of the digits, right? To go back all the way to the beginning. Oh boy. The sum of the digits of the expanded number, okay? Well, the sum of the digits of the expanded number, this is our expanded number. It's basically 128 followed by a whole bunch of zeros like that, and there's a 300 of those zeros. Well, the sum of the digits are going to be 1 plus 2 plus 8 plus 0 plus 0 and so on. So the only digits that contribute to the sum are 1, 2, and 8, and 1 plus 2 plus 8 is 11. So there you go. 11 is the answer, and that means number 22 is A. And if you have a shortcut to this question, please by all means type it below in the comment section. Triangle ABC is isosceles with AB equal to AC, and BC is 65. P is a point on BC such that the perpendiculars distances from P to AB and AC are 24 and 36 respectively. The area of ABC in centimeters squared is. So let's label this and proceed from there. First I'll draw a perpendicular from A all the way down to the bottom like that. Okay? And then I will draw the lengths and the angles. So this perpendicular, like that. And then they give us some of these, right? They give us, this is 24, this is 36. And in terms of angle, since this is isosceles, if this is x, this is also x, the angle. And therefore, this will be 90 minus x, this angle in here. 90 minus x. And very similarly, this is also 90 minus x, this angle. And I think that should be it. This angle is also 90 minus x. And as is this one. So this is going to give me a lot of similar triangles. This B to P, I'm going to label A. And therefore P to C is going to be 65 minus A. Because they tell you that the whole length is 65, B to C. All right, I think that should be enough. The only thing is from B, this point right here is the midpoint. And that is going to be giving you a distance of 32.5 from there to there. So I'll just call that M. So from B to M is 32.5, right? Because it's just half of 65. So I'll just put that in there. But don't get confused. 32.5 is not the value for A, right? Because it kind of looks like that. It's the value from B to M, all right? Because P and M are different points. So I'll just put that in there. I hesitate to put that there because you might get it confused, but you know that it's not the same. Okay. Now there's a whole bunch of similar triangles, so I'm going to explain how I'm doing this. First and foremost, look at these two triangles right here. We got this one, and we've got this one. They are similar. Why are they similar? Because they have the exact same angles. So that means that this side, 24, over that side, 36, is equal to this side over this side. So that would be A over 65 minus A. And very quickly we can therefore solve for A. So this looks like, if you cross multiply, 1560 minus 24A is equal to 36A. And therefore 1560 is equal to 60A. And therefore A will be 26. So I'll put that in there, 26. And therefore 65 minus A, that gives me 39. All right? So very quickly we were able to get A. Now, I think I'm going to need at least one of these, either this one or that one. So either one is sufficient. I'll just use that one. So the distance from R to B. Okay? That one I can get through Pythagoras. So B squared plus 24 squared is equal to 26 squared. And therefore B squared is going to be 676 minus 576. B squared is equal to 100. And therefore B is 10. All right, great. So I put that in there. B is 10. All right, I think we're pretty much gotten most of it now. Now we use one final similar triangle, and that's the big one. This big one here. That triangle and this triangle. They are similar. Why? Because they have the exact same angles. So AM, which is from there to there, which you can call height, or I'll just call it AM just to avoid introducing yet another variable. AM over 32.5, right, which is the base, is the same in this triangle as 24 over 10. All right, if you match up the sides according to their angles. So this basically means AM, if you do the math here, will be equal to 24 times 32.5 divided by 10, and that gives me is 78 for AM. And that's it. Now we have one final calculation, which I think I can squeeze in here without having to scroll down, which is the area. The area of ABC is 1/2 base times height. It's a triangle. The base is 65, right? B to C. And the height we just figured out, AM, was 78. And if you do the math here, you will get 2535. And therefore, the answer to number 23 is D. The polynomial f at x satisfies the equation f at x minus f at x minus 2 is equal to 2x minus 1 all squared for all x. If p and q are the coefficients of x squared and x respectively in f at x, then p plus q is equal to. So they give us a polynomial, but they don't tell us what degree it is, and I really wish they would, because they would avoid me having to guess. All right, no problem. Let's try ax squared plus bx plus c. I'm guessing that it's a second degree polynomial. Now they tell me that p and q are the coefficients of x squared and x. So instead of a's and b's, I can put px squared plus qx for f at x. Okay? All right, let's go for it. Let's put in our values into that equation. So we've got px squared plus qx plus c minus. Now we got f at x minus 2, so I'm going to put x minus 2 squared plus qx minus 2 plus c is equal to 2x minus 1 all squared. So this becomes px squared plus qx plus c. And then let's see here, we've got px squared minus 4x plus 4 plus qx minus 2q plus c is equal to 2x minus 1 all squared. And then let's see if we try to collect like terms, what happens. So be careful, just don't make any algebraic mistakes here. Minus px squared plus 4px minus 4p minus qx plus 2q minus c is equal to 2x minus 1 all squared. Let's see, collect like terms. These guys go, the qx goes, the c's go, and all you're left with is 4px minus 4p plus 2q. And if I expand that one, I get 4x squared minus 4x plus 1. Okay, well, I can't match things up because there's no x squared here. So, and this is 4. So what does that mean? There's no x squared on the left side. So that means that my polynomial was not a second degree. It has to be higher. So most likely it's a third degree. And I really wish they would have told me that in the question, you know, because you've got limited amount of time as it is on a math contest. And then when they don't tell you that, you've got to experiment and waste several minutes doing this. All right, no problem. Let's start again, this time with a third degree polynomial. Okay, so I've got my third degree polynomial, and instead of a's and b's, I'm going to put what they tell me, which is that for x squared the coefficient is p, and for x the coefficient is q. All right, okay, let's try this again. f at x minus f at x minus 2 is equal to 2x minus 1 all squared. So I've got ax to the power of 3 plus px squared plus qx plus d minus, now I've got to put in x minus 2, so ax minus 2 to the power of 3 plus px minus 2 squared plus qx minus 2 plus d. And that is equal to 2x minus 1 squared. All right, this guy here, I'm just going to expand it up here to save a little bit of time having to write everything out. X squared minus 4x plus 4, right? And I can therefore expand that. So we've got x to the power of 3 minus 6x squared plus 12x minus 8 if you collect like terms. Okay, let's do this now. Px squared plus qx plus d. And this looks like, all right, be careful here, minus ax to the 3 plus 6ax squared minus 12ax plus 8a. And in a very similar way, so I don't have to write it all out again, I'll just do this up here. X squared minus 4x plus 4. That helps me save a little bit of time. Minus px squared plus 4px minus 4p, and then the rest should be pretty straightforward as long as I don't make any mistakes. Minus qx plus 2q minus d is equal to 4x squared minus 4x plus 1. All right, here we go. Now let's collect like terms. The ax to the power of 3's go. The please don't tell me that they're all going to disappear again. And let's see here. Okay, good. We got something for x squared. All right. I don't want to go back and try a 4th degree polynomial. All right, so it takes care of that one. And now we got to collect like terms to figure out what's the coefficient in front of x. So it looks like it's some of these cancel. Plus qx minus qx, and then minus 12a for this guy, plus 4p, and then the d's cancel, and then you're just left with minus 4p plus 2q. Okay, so now we gotta basically match up the coefficients. Okay, so that means 6a is equal to 4, and therefore a is equal to 4 over 6, and that means a is equal to 2 over 3. And then this coefficient is equal to minus 4, so that means that minus 12a plus 4p is equal to minus 4. So minus 12 times 2 over 3 plus 4p is equal to minus 4. And that is 12 divided by 3 is 4. 4 times 2, negative 8. Plus 4p is equal to negative 4. So 4p is equal to 4, and therefore p is 1. And now this is equal to 1. So 8a minus 4p plus 2q is equal to 1. 8a, a is 2 over 3. Minus 4p is 1, plus 2q is equal to 1. So the 16 over 3 minus 4, and bring the 1 over, minus 1 is equal to negative 2q. Get common denominators here, 3 and 3, 3 and 3. So we got 16 minus 12 minus 3 over 3 is equal to minus 2q. So 16 minus 12 is 4, minus 3 is 1. So 1/3 is equal to minus 2q. And therefore q is equal to negative 1 over 6. And they want you to find p plus q. So that's 1 minus 6, which is 5 over 6. So there you have it. 5 over 6 is the answer, so 24 is B. A steel cube has edges of length 3, and a cone has a diameter of 8 centimeters and a height of 24 centimeters. The cube is placed in the cone so that one of its interior diagonals coincides with the axis of the cone. What is the distance in centimeters between the vertex of the cone and the closest vertex of the cube? The first thing, of course, is I'm going to elaborate on this diagram right here that they have given in the question. So here is the diagram. Basically, there's this cube that's been placed inside this cone. And the hardest part, of course, is the visualization of how is this going to work. So I'll try my best to explain it in steps. And I'm going to first label these points right here. This one, that I drew the small red dot, that one, and that one. Now those are, of course, vertices of the cube. Now those three in particular are very important. Why? Because those three touch the cone. Okay, I want you to visualize that. Now this one and this one, that's pretty obvious. You can see, oh yeah, no problem. Those touch the cone. But this one touches the cone also, but facing you. See what I mean? So that's the first thing that you have to understand in this question. And then the next part is I'm going to join those three dots that I just drew. And when I join those three dots, I want you to be convinced that those three dots form a triangle that is equilateral and is on the same plane. How do I know that it's equilateral? Because look at the sides. Each side represents what? It represents the diagonal of one of the faces, correct? You can clearly see that. And therefore, since each side represents the diagonal of one of the faces, all three sides are the same. And now I will label the vertices. I'll call this A, I will call this one B, and I'll call this one C. And later, I will of course work with the rest of the vertices, but I'll just label this one here that's at the very top G, and this one here F. Okay? So that is my step 1. Step 2 is something I just touched on, and that is this triangle that I've drawn between A, B, and C. I will draw that next, but I'll draw it from a bird's eye view, completely as if you're looking down on it. So here's that triangle again. A here, B here, and C here. But this is a bird's eye view. Now I want you to be convinced that each of these sides is the length of a diagonal of one of the faces, and I'll call that D. So this is D, that's D, and that's D. Now how do I figure out the length of the diagonal of one of the faces? Well, that shouldn't be a problem. Just draw one of the faces on the side here, and then draw a diagonal and use Pythagoras, correct? The question tells you that the cube has side length of 3. So this is 3 and this is 3. So figuring out the diagonal is just Pythagoras. So that's 3 squared plus 3 squared is equal to D squared. And therefore this is 9 plus 9 is equal to D squared, which is 18. And therefore D will be the square root of 18, which is 3 root 2. All right, so I'll put 3 root 2 right there. And please remember that these three, A, B, and C, are the vertices of the cube that touch the inside of the cone. Okay, now that we have that established, let's move on to our next part, part number 4. Part number 4 is using this diagram right here, but understanding that this is a cone. So remember, at the top of the cone, you have this circle, right? Just like any cone, the top of it, an ice cream cone, for example, will be in the shape of a circle. Now, of course, in my diagram, it looks like an oval, but that's just because of the way it's been drawn. But if you look at it from a bird's eye view, it will be a circle. Very similarly, since A, B, and C are on the same plane, if you made a cross section, they would be part of a circle, like that. So that is the next diagram I'm going to draw. So there you go. There's our diagram again. This is A, this is B, and this is C. Now what I'm going to do is I'm going to draw perpendiculars from each vertex to the other side. So from C, I'll draw one like that. From A, I'll draw one. And from B, I will draw one like this. Now I want you to pay close attention to this line right here, from the center to B. That represents the radius of that circle, okay? From there to there. And the radius of that circle is going to be very important. Now we can figure that out pretty easily. We know the distance from here to here is D, right there. And D we figured out was 3 root 2. Now, if this whole distance is 3 root 2, then the distance from here to here is 3 root 2 over 2. Why? Because that perpendicular will cut that side in half. Now, how do we figure out R? Well, we take into consideration that this is a right triangle, and since this is an equilateral triangle, each of these are 60 degrees, and therefore this one, if you cut it in half, would be 30, and therefore that's 60. And that is a 60, 30, 90 triangle. So if you have a 60, 30, 90 triangle, the ratio of the sides are 1, 2, and root 3. So since we have one side as 3 root 2 over 2, we can figure out R. R over 3 root 2 over 2 is equal to the ratio, which is 2 over root 3. So that means root 3 times R is equal to 3 root 2, and therefore R is equal to 3 root 2 over root 3. And if you rationalize the denominator, you will get root 6 for R. So that takes care of that step. Now the next step is I want to draw the entire figure once more, concentrating on what we have already discovered. So let's label some points now. At the very top is going to be G, and this is going to be C right here. This I will label just O, and then at the very bottom here, I'll just draw a red dot to represent that these two are going to represent a height, and I'll call that H. Okay, and finally I'm going to label the other vertice of the cube right here, and I'll call that F. And finally, this height here, I'll call small h. And remember, just in case you're wondering what is G, F, and C, G, F, C right there, those represent vertices of our cube. Here's G, here's F, and here's C. Okay? So now we have to use similar triangles to figure out the relationship between our H and our R that we figured out right here. And you remember in the question they told you that the diameter is 8 and the height is 24 of that cone. So that means that this is 8 from there to there. And from there to there, therefore, is 4. And this whole height from top to bottom is 24. So I'll put that on the side there. And then we're going to use these triangles, the big one and this one right here, to figure out a relationship between the height and R. So from the big one, we have 4 over 24 is equal to R, which is right here, the distance from O to C, over H. So this gives me 1/6. R I figured out over here was root 6. And therefore H is equal to 6 root 6. Now we get to our next step, is concentrating now on the distance from G to F, right there. Now G to F, they have actually told you in the opening stem, it represents a diagonal between two vertices on the big cube. The cube is placed in the cone so that one of its interior diagonals coincides with the axis of the cone. And what that means is that the distance from G to F is one of the interior diagonals. So we have to figure out the length of that. So here is my cube, and G is here, this vertice, and F is down here. Okay? So that diagonal between G and F is what is the value for D. That is what coincides with the axis of the cone. So to figure this out, it's a two-step process. First, I've got to figure out the diagonal of one of the faces, and then I can figure out the diagonal of the entire cube. So they gave us that the cube has side lengths of 3. So this initial D, I have actually already figured that out up here. 3 root 2. So, no problem. D is equal to 3 root 2. And then now I've got to figure out GF. Well, this side is 3 because it's just one of the sides of the cube. And therefore GF squared is equal to 3 squared plus 3 root 2 squared. Like that. And therefore GF squared is equal to 9 plus 18. That's 27. And therefore GF is the square root of 27, which is 3 root 3. Okay? And now we are getting to the conclusion of this question. Since we have the value for GF, we now have to figure out the value for GO. If we do, we can subtract that from GF. That will give me OF. And then I can then subtract OF from H to figure out my small h, which is the distance from the vertice of the cone to the closest vertice of the cube, which is F. So here we go. The next step is to figure out the value for OG right here. And to do that, I will draw a line from G to C like that, creating a right triangle. And that gives me that OG squared plus R squared, which is OC, from there to there, is equal to GC squared. OG squared plus R squared. R we figured out earlier was root 6. And GC, well, what is GC? GC, if you look at this original diagram, is just the distance from one vertex to another on one face. So it's the diagonal of one face. The diagonal of one face, we figured out right here, is equal to 3 root 2. So GC is 3 root 2 all squared, like that. So this gives me OG squared is equal to 3 root 2 squared, which is 9 times 2, which is 18, minus root 6 squared, which is 6. And therefore OG squared is equal to 12, and therefore the root of that is 2 root 3. Okay? And then now we have to figure out the value for F to O. Okay, no problem. F to O is equal to basically GF, this whole distance, minus GO. So that's GF minus GO, or OG, same thing. GF we calculated over here was 3 root 3 minus 2 root 3, and that is just root 3. And now our final step is to figure out this small h. Small h is just big H minus FO, and that would be 6 root 6 minus root 3. And just to recap, what is exactly the definition for small h? It is the distance between the vertex of the cone and the closest vertex of the cube. And that we calculated to be 6 root 6 minus 3. And therefore, number 25, the answer is A.